As we move into transformations of functions, before we do that, we need to become familiar with 7 common functions. And by becoming familiar with it, what I mean is that you need to be able to rapidly produce a table of values, know the domain and range of the function, and whether it's increasing, decreasing, or constant. And you need to be able to very comfortably and quickly make a sketch using a table of values for each of these functions. Once you can do that of the basic function, then the transformations become very straightforward, and you see how each of the constants or each of these functions shares the same characteristics when we do transformations. So this is just an introduction to each of those 7 functions, and so we'll just go through them one at a time. So hopefully you've got some scrap paper, or sorry, graph paper, or you've printed off this so that you've got the graphs on this sheet that you can fill out as we go along. The first function that we're looking at is the constant function f at x equals c, where c can be any real number. So think of that in terms of y equals some number. And for this one, we'll use a specific example, f at x equals 5. So if we think of the table of values for that, let me just see if I can get my pen to cooperate. Here we go. If I choose values for x and come up with the y values for them, it's going to be 5 all the time because y is constant. So there's the table of values, and we can sketch that graph. So -3 is 1, 2, 3, 4, 5. We've just laid out these points. And if you recall, y equals 5 gives us, in fact, a horizontal line through y equals 5. Okay, so the domain of this function is -infinity to infinity. The range is only 5. Or we could just write that as 5. It's increasing? No, it's not decreasing at all. It's constant over the whole domain of -infinity to infinity. Okay, and is it odd, even, or neither? It's actually an even function because it's symmetrical about the y-axis. Okay, so let's take a look at our next function. This is called the identity function. It's f at x equals x. So think of it in terms of y equals x. So again, let's come up with a table of values. And when you're actually sketching these, you may find that you don't actually need the table of values, but it's helpful to see it the first time that you graph it. If y is equal to x, then when x is -3, y is -3. And likewise, -2, -1, 0, 1, 2, and 3. So we've got the point -3, -3, -2, -2, etc. And we have a straight line that goes through the origin at a 45-degree angle to the x-axis. And again, if we look at domain and range, we can see that the domain is -infinity to infinity. The range is the same, -infinity to infinity. It's increasing over the entire range. So domain, I mean -infinity to infinity. It's never decreasing, and it's not constant. And as far as symmetry goes, this is an odd function. If I rotated it 180 degrees, it would look exactly the same. The third function is the absolute value function. F at x equals the absolute value of x. So let's create the table of values for that again. -3 up to 3. And let's plug in the absolute values. So the absolute value of -3 is +3. And so we end up with these values. Okay, so if I plot those, I've got 0, 0, and I'm going like this. Okay, so we've got sort of a V-shaped graph that goes up and to the left and up and to the right from the origin. So the domain of this function, all the x values, negative infinity to infinity. The range is actually 0 to infinity. And actually, I should have a square bracket there. Let me just put that there because it can include 0. It's increasing. This, if you look at this function, it's increasing from 0 to infinity. And it's decreasing from negative infinity to 0. And sorry, but those should have been round brackets. Let me just fix those up. And it's never constant. And if we look at the symmetry of that function, we can look at it and see that it's even. It's symmetrical about the y-axis. Our fourth function is the quadratic function, f at x equals x squared. So again, let's come up with a table of values for that using the values of x from -3 to +3. And we're squaring the x values to get our y value. So we'll have 9, 4, 1, 0, 1, 4, 9. So let's plot those points and take a look at the shape here. So I've got -3 and 9, -2 and 4, -1, 1, 0, 0, and okay, so I've got those 7 points. This one, you're not using a straight edge for your making a smooth curve through those points. Okay, so the domain again, this we're putting arrows on it. The domain, it actually goes from negative infinity to infinity, so it goes left and right on forever, and it goes up forever but not down forever. So our range is, like the absolute value function, is 0 to infinity. It's increasing from 0 to infinity. And it's decreasing from negative infinity to 0. It's never constant, and it's also an even function because it's symmetrical about the y-axis. And our next function is the square root function. F at x equals the square root of x. So let's create a table of values for this one. And I'm going to pick specific values of x to make it easy to come up with our values for y. So I'm going to do -4, -1, 0, 1, 4, and 9. And y is the square root, and we're using the radical symbol, so we're only thinking positive root. Y is the square root of those. Okay, so square root of -4 is actually not defined, is it? Square root of -1, same thing. The square root of 0 is 0, square root of 1 is 1, square root of 4 is 2, and square root of 9 is 3. So we can plot those points 0, 0, 1, 1, over 4 and up 2, and over 9 and up 3. And we end up with, again, sort of a curve. So use a curve for that, not a straight edge. And it looks like half of the shape that we graphed in the previous function. So if we look at our domain here, our x values go from 0 to infinity, and they include 0. Our range also goes from 0 to infinity. It's increasing over its whole domain, so it's increasing from 0 to infinity. It's never decreasing, it's never constant, and it's neither even nor odd, because it's not symmetrical about the y-axis and it's not symmetrical about the origin. Okay, we're down to our last two functions. Number 6 is the cubic function. F at x equals x cubed. And let's go from x being -3 to +3 again. And create our table of values. So y, or the f at x, is x cubed. So -3 cubed gives me -27, Negative 2 cubed gives me negative 8. Negative 1 cubed gives me negative 1, 0, 1, 8, and 27. Okay, so let's plot those points. We actually can't plot the extreme ones because our graph doesn't go down to negative 27 or up to positive 7, but that helps us to figure out the steepness of it. So if I do negative 2 and negative 8, negative 1, 0, 1 and positive 1, and 2 and positive 8. So this to the right, it's a fairly steep curve upward, and to the left, if it's a fairly steep curve downward. Okay, and that's the cubic function. So the domain of this, it actually goes left and right continually, so negative infinity to infinity. The range also negative infinity to infinity. It's increasing over the entire range. So as we go from left to right, it's always increasing. So negative infinity to infinity. It's never decreasing or constant, and this is an odd function. If we rotated it 180 degrees, it would look exactly the same. And our final function is the cube root function. And again, for this one, I'm going to mastermind the x coordinates so that our y's turn out nice. So if I go from negative 8, negative 1, 0, 1, and 8 for my x values, and then take the cubed root of those, I end up with negative 2, negative 1, 0, 1, and 2. So let's plot those points. So negative 8, negative 2, negative 1, 0, 0, 1, 1, and over 8 and up 2. So this is a lot like the previous graph, but sort of flipped onto its side. Okay, so if we look at that function, we can see that the domain goes from negative infinity to infinity. The range, same thing. It's also continually an increasing function. As you move from left to right, it's always increasing. It's never decreasing, never constant, and this one is also an odd function. If we rotated it 180 degrees, we'd end up with exactly the same spot. So these 7 functions, please be very familiar with them and bring a graph of them to class, next class. And I'll see you then.